Okay, really quick, desuperheating circuit. So right here, this is your desuperheater valve. This is just solenoid valve. It's connected to the bottom of this liquid line right over here, right? So what happens is, right, you follow this. Now this is the suction side of this compressor suction group over here. You can see that this suction group, this suction header right here, is on a different group than this one over there, right? So it has its own suction group right there, right? So what happens is, this thing right here, this solenoid, well, there's a temperature sensor. So there's a temperature sensor right there on this suction header, right? So that temperature sensor sends a signal over to our controller on the other side, right? And there's also one other temperature sensor on the discharge side too. And that controller interprets that information. If it says, this is too hot over here, what it does is it now sends a signal to this solenoid valve, opens up the solenoid valve, sends liquid refrigerant to this TXV. Now that sprays that liquid refrigerant into this suction line, cooling off the suction line. Now you can see the bulb of this TXV is all the way over here. See? Right there. So what this desuperheating is doing is it's cooling down the vapor refrigerant as it goes to the compressor over here, right? So why is it doing that? Because the compressor manufacturers, right? So what you got to do is you got to go over to your compressor, look on the side of your compressor, find your tab, there it is right there. Go to your compressor manufacturers, and we'll do that in a little bit, and it's going to have a superheat, which means the temperature of vapor refrigerant going into the backside of the compressor in order for this compressor to run properly. Because if it goes in too warm, these compressors are going to overheat and it's going to start breaking down and not functioning right. If it goes in too cold, you're going to be putting in liquid refrigerant into your compressor and you're going to blow it apart because you can't compress a liquid. So you need this happy medium where you need refrigerant that's cool enough to cool off your compressor as it's running, because your compressor is using that refrigerant to cool itself. So let's say this is coming in at 30 degrees. It's using that refrigerant as it touches the inside of that compression chamber in there. It's going to cool itself off. So this desuperheater valve lowers the superheat, just the temperature of this suction line, in order to keep our compressors operating properly. So now we're going to take a quick look at the controller. So basically, in a nutshell, just really quick before we go to the controller, if this gets too hot, that solenoid opens up, sprays liquid refrigerant, and cools off that suction line all the way to the header, giving the compressors a cooler gas to compress, cooling off the compressors and keeping them working efficiently. Now we're at the controller, and here, right, we got to go to configuration, control, news, and calculations on a Danfoss controller. Sometimes they'll have it set up just like a normal refrigeration thing, but in this case it's in calculations. So that's, going to hit you're going to hit your settings, configure, control, miscellaneous, and calculations. So now we're on here, which is calculation, right? So we're going to go back. We're just going to go back one, right? So if I go into the calculations, you can see the CA3 is desuperheat, and it's on right now. So we're going to click on there, right? So if we look at, we got this input, which is S1, and then we have another input, which is S3, right? So we're going to go down. So this S1 is the suction temperature. So if we look over here, greater than number 2. So number 2 is 68. So basically it's saying if the suction temperature, right, is greater than 68 degrees, we are going to turn on the superheat with a desuperheater. Does that make sense? So if that temperature probe that we saw earlier over here, right on this header, right here, if that temperature probe gets over 68 degrees, that superheat solenoid valve activates, turning on the desuperheater. Now we're going to go down to this one. This is the discharge temperature. Okay? If the discharge temperature is over 220 degrees, the desuperheater is also turned on. If either one of those cases happen, it will turn on the desuperheater. So if you look at over here, the discharge is right here, right? And I'm not entirely sure where that temperature probe is, but I'm guessing it's probably somewhere on this discharge header. And we'll see if we can find it. Looks like that temperature probe's right there. If this area gets over 220 degrees, turns on the desuperheater valve. Sometimes on the wall of your machine room, you're going to have this chart with all this useful information, right? It's also stored in the rack. I'll show you that in a minute. So we're going to go down here. We're going to desuperheater right there. Low stage, load, okay? Now it gives you the BTUs that TXV is rated for. And from there, if you look at, there's nothing else in there. So this basically gives you, this is the desuperheater, the load, and this is what the TXV needs to be rated for to do. Now, if you're looking at it, you're like, this is the TXV, therefore it's going to have a superheat of some sort. Basically, the rule of thumb is you put the valve in the way that it is, you don't set superheat. You put the valve in, and then you assess the temperature down the line, and you try to see if it's causing any liquid refrigerant or anything like that that's happening. And we'll go into that a little bit further in the video. But basically, that's how you determine what size TXV you need, as well as, you know, looking at it and replacing what's there. Now, the last thing I wanted to show you is a lot of the times that same chart is right in here. It was just a darker area, so I didn't want to use it. I just wanted to show you super quick. So this is a service guide for 6D compressors, okay? So we're going to go down to, we're going to go down and we're going to look for the parameters we're looking for. So if I go down to page 17, it was, right? So it depends on your compressor make and model and the company, you know, and how they want to set things up. But right here, right, we're on page 17. This is a typical 6D compressor operating limits, okay? So look at this, return gas from medium temp and duty, right? 65 maximum, right there, you see, okay? Now if we look over here, preferred return temp for low temp and duty, 35 to 50 degrees Fahrenheit, you see. And now even over here, you have max temp at discharge is, 275 from the service valve, 250, okay? So you can see that, based on our Danfoss controller, what we had, those parameters that were set. So we had a parameter, instead of 65, we had 68, okay? And then for the max discharge that we had, 225. So why did they pick those? I don't know. Maybe the engineering thought that would be the way that it was. The rack is 20 years old. Maybe the parameters were less stringent back then on the return gas, but it was more stringent on the discharge. I'm not sure. But basically what they're doing is if the discharge is too hot, right, it's going to warm up the compressor, okay? So during a very hot day, your condenser cannot expel the heat from your refrigerant gas well enough. So this top head of your compressor is going to be like 255, degrees or whatever it is, right? And so what they do is, that's why on the Danfoss controller, you have the desuperheater is to turn on if this is 225 degrees. Because what it's trying to do is it's trying to feed colder refrigerant into the back of the compressor in order to cool the compressor, because this is going to be super hot. That discharge side of the compressor is going to be super hot in order to keep up with the load on the system. Now on the other side of it, when this value, the suction side of the compressor, is above, in our case it was 68, right? It turns on the desuperheating valve in order to cool the return gas to make sure that compressor stays at the proper operating temperature. Now we're going to go to the pen and paper and take a quick look at it. Just mentioned some more further stuff in the manual. So if we go to this page 3, there's like general compressor information for your 060 compressor, right? So if we look at our model, it's actually, even though it's targeting like a 20-ish degree evap coil, it's a 6DR, so it's actually a low duty compressor. So based on what we just went over on our compressor specs, this is actually more than likely targeting the wrong value. It should actually be targeting about 50 degrees as a maximum So you know, I wouldn't recommend as a technician. So you see right there it says for low temp duty 35 to 50. Okay, and so I wouldn't recommend as a technician just going, you know, John Wayne and just changing stuff. I would definitely recommend talking to your engineering department if you have it, or you know, your boss or somebody, and just kind of go over, you know, I think we have grounds to change this possibly. But I just wanted to show that to you, that you know, you just definitely verify with the compressor nameplate on what you're doing. And yeah, so I'm just gonna jump to some compressor spec information for you really quick, and yeah, we're gonna take a look at that. So right here, that your compressor spec information. Trying to rotate the string, trying to get it. So right here, you can see how it says suction temperature, right? So we're gonna go over here. It's a 6DR72, 6DR72. So we got this right here. 7246 right there, right? That's our model, and we can see that it's -40 to 25. So that's the range of the evap coil, and right now it's targeting around like 20-ish. So I just want to use that as the backdrop. Now we're going to take a look at a quick diagram. I'm just going to kind of explain it. Alrighty, so real quick, this is kind of a model of our system. So right, you have your compressors. On this side of your compressor, you have your discharge, goes to your condenser. Out of your condenser, you have your liquid line. Now, this is just an example. Before your liquid line, you come down here, you know, you got a case. So this is like a case on the floor. So you have your TXV, your evap coil, and then from there it goes back to your suction header. All right. Now, off of your liquid line, you're gonna have your desuperheating circuit. Okay. So you have this solenoid, then you got a TXV, you got a sensing bulb on the TXV. So what happens is that your Danfoss controller, and in this case it's the Danfoss controller that we have, right? It has a T equals 225 max. So when this discharge line is 225 degrees, it goes turn on the solenoid. That refrigerant flows to this TXV, and that puts liquid refrigerant into your suction header. Okay? And you might say, well, liquid refrigerant in your suction header, you don't want your compressors to explode, right? So at the temperature max, more than likely it's going to be so warm that this is going to evaporate and become a vapor before it ever gets to the compressors. And so the whole point of this is to cool that line down in order to cool the compressors down, okay? So it does that when the discharge is a 225 max, because as I mentioned earlier, it's heating up the compressor by doing that. And it also does that when the suction line is at its max temperature. What in this case, they set it the 68. And as we saw by the manual, it might be that we should actually set it to 50 as a max. Now, I also wanted to mention this over here, where there's a couple, it's going to sound kind of crazy, but there's a couple different kinds of superheat, right, in your system. So you have your superheat across your evap coil in your case. In this case, we're just using the example of 8 degrees of superheat because the pressure is giving us a 22 degree coil, and at the end of the coil, it's 30 degrees. So it increases in temperature from the beginning of the coil to the end of the coil by 30 degrees. Now you have a superheat to your rack. And so what that is that's the temperature increase from your case to your suction header. So, you know, if you're in a machine room, you're going to see a bunch of circuits going into your suction header. And if you were to take your temperature probe and put it right on that circuit right before it enters the header, you're going to get this temperature difference between your case and there. And that's called the superheat to your rack, or your superheat to your compressor. And the rule of thumb is around 20 degrees. Okay? And in a Copeland manual for Copeland compressors, I've actually seen them state 20 to 25 degrees in their actual manual. So refer to your compressor manual. And the reason they do this is because they want to increase the temperature to a point where if you look at this, 50 right, is what the manual actually says should be around, like the max temperature that these compressors can handle, right? So it's the max temperature that these compressors can handle that can cool the compressors properly, and that there's not going to be any liquid refrigerant entering those compressors. Okay? Now the superheat over here, right, for this Desuperheater. So this Desuperheater, if let's say this is high, let's say this is like this is now like 80, right? Like let's say all the doors are open, or the AC doesn't work in the store, and the store is like 90 degrees or something. So that superheat is way too high. Okay, this Desuperheater turns on to cool down those lines in order to offset that, so the compressors don't overheat and burn out. Now this superheat is concerned with if you were to take a temperature. Now we saw that the temperature probe was on the suction header, okay, and that's kind of like an estimate, okay, of it, because some places are more thorough and other places aren't. But basically we care that right before this compressor, right there, like just right before it, that is where it's 68 degrees. It should not be above 68 degrees right before it. That is what we care about. So we have this superheat for the TXV, right? So I told you guys that when you install this TXV, you're more than likely going to install it to just factory default, and you're going to put that sensing bulb as far down that line as you can. Now, if you're noticing that when this Desuperheater is on, you're getting like a colder superheat down there, like a negative superheat, or just a very aggressive like 1 degree of superheat, you're flooding out your compressors. Okay, so that's where it's kind of it's up to you to, after you install the new TXV, to just check if the Desuperheater is on, because it's not going to be consistent. It's going to change based on your load, so it's kind of hard to judge. But to the best of your ability, like let's say if it's targeting 68 and the temperature's like 72 or something, and you turn it on, okay, that is a good setting, because that is a lower. So if you're gonna flood back, it's gonna be at this temperature that's closest to the max, okay? Because if it was at like 100, your liquid refrigerant would vaporize the moment it flash off, the moment it goes into the suction header. So it's better to set it closer to that value that you're set for. So yeah, so that's basically your desuperheating circuit, kind of how it works, kind of how you would set it. And yeah, so please, that's how you do it. So yeah, like, subscribe, all that, hit the bell. Yeah, thanks.